Algebra 2, Section 1.1, Parent Functions and Transformations, Notes. The first thing I'd like for you to do is, on your note sheet, take a look at these basic parent function graphs. So you're not going to work with a partner, you're going to work on your own, and I want you to try to match as many of the graphs with their names as you can. So here are all the different ones that you'll see below. Constant function, linear, absolute value, quadratic, square root, cubic, reciprocal, and exponential. Now I know some of these you probably not have had before, but some of them you have. So again, pause the video for a moment, go to your note sheet, and just underneath the graph, try to identify them. When you've identified as many as you can, then come back and unpause the video so that you can see how you did. So pause the video now. Okay, check and see how you did. So A is a V-shaped graph, and that's the graph of an absolute value function. B is a curve just on one side. It is a square root function. You may or may not have seen this before. C is a straight line. It's a horizontal line, but that is definitely a linear function. D is an exponential function. You might remember this curve from Algebra 1. It starts increasing slowly and then more quickly as it goes up. E is what we call a cubic function. You probably have not seen this before. So again, any of these that you're not sure about or that you guessed incorrectly, just change the name. F, of course, is a line. It's going through the origin, and so it is a linear function. G is probably a new function to you. It is called a reciprocal function. And then finally, we've got on H a quadratic function. Now I would like for you to circle graphs A, C, F, and H. These are the functions that we're going to work with this unit. We will get into some of the other functions later, but for this unit, and in particular for this section, we're going to focus on the linear function, the absolute value, and the quadratic function. Now look at the bottom of the first page of your notes. So here are graphs of the main functions that we're going to look at for this unit. And we're going to think of them in terms of families. And each family has a parent in some way. And so we have just the most basic equation of this function family is called the parent function. And you've got that term right here. Now I'm going to rewrite these in equation form. We're going to think rather than a constant. This is another example of a linear function. So, linear. Change that name to linear. Now, in equation form, we can replace f of x with just a simple y. So this could be the graph of y equals 1. If this right here were 1, then no matter what x is, y is going to be 1. So that's a horizontal line straight through where y is 1. This is the graph of f of x equals x, or y equals x. It is the most basic form of the function or the equation of a line, a linear function. The next one is absolute value. You can think of that in equation form as y equals absolute value of x. No matter what input that you have for x, y will always be positive because you'll take the absolute value. So this is a V-shaped graph. Notice that its point here, this is called its vertex, is at the origin, which is 0, 0. Also notice that it opens up in its most basic graph of its most basic form, the parent function. Quadratic function is y equals x squared in equation form. Notice, whoa, on this one too, that the vertex, or the lowest point here, is also at the origin, at 0, 0. And then it also opens up. What you want to know about these are the most basic form of the equation. So know the basic equation. And then you also want to know the basic shapes of the function. So for example, of the parent function linear, you want to know that is a straight line that goes through the origin and rises as you look at it left to right. You'll want to know that absolute value is a V-shaped graph that has its vertex, that's the bottom of the V, at 0, 0. And you'll want to know that quadratic is a U-shaped graph with its vertex also at 0, 0, and that it opens up. The next thing that we're going to do to look at these functions is we're going to graph them. And so we're going to review how to graph a function using a table of values. We're going to look at our first function as a linear function. So we're going to graph f of x equals 2x plus 4. Let's write that in equation form just in this space in the table. So instead of f of x, it's y equals 2x plus 4. And then in the second graph, we're going to graph the function g of x equals negative x plus 2. So let's write that in equation form, which is y equals negative x plus 2. So our directions say review how to graph using the slope m and the y-intercept b. So since we are in slope-intercept form, which is y equals mx plus b, let's graph the first function using those. So my slope is my number in this position. So slope equals 2. My y-intercept is this. So b equals 4. Now on your graph, you want to draw an xy axis and label x and y. Then you want to label a scale. So I usually just label 5 and 5. Just one number on the x and one number on the y-axis. Now remember, when we graph using slope-intercept, the first point goes right on the y-axis at that number at 4. And then think of your slope in fraction form. So it's rise over run, so up 2 and over 1. And you can do that a couple times. And then draw a line straight through, and there is your line graphed. Now let's review how to plug in values. I would like for you to plug in a negative, a 0, and a positive value. So let's just make it simple, and let's plug in negative 1, 0, and positive 1. So negative 1 times a negative is positive, which is 1 plus 2 is 3. 0 plus 2 is 2. And then if I plug in 1, I get negative 1 plus 2, which is 1. Draw your xy axis, label your scale, and then plot your points. So negative 1, 3, 0, 2, 1, 1. Draw your line. Also put arrows at the end, each end, to indicate that that just goes on forever. There, now that's just a review of how to graph linear function, either using slope-intercept or just simply plugging in values for x and finding out what y is. And when we plug in values, we make sure to plug in a negative value, at least 1, 0, and positive to see what the graph is doing in each of those locations. Now, if you compare it, look back on the front side of your notes to the parent function, you can see that it's a little different. Remember that the parent goes through the origin, and that increases as you look at it left to right. So these, because of the values in the equation, have all changed a little. Now let's look at how to graph an absolute value function. So we're going to graph the function f of x equals the absolute value of x. Or in equation form, that's y equals the absolute value of x. And then our second one, we're going to graph g of x equals the absolute value of x plus 3. In equation form, that is the absolute value of x plus 3, y equals. So we're going to plug in a negative, 0, and positive. So again, let's make it simple. Negative 1, 0, and 1. We plug in negative 1 for x into the equation. I kind of missed there. The absolute value of negative 1 is 1. The absolute value of 0 is 0. And the absolute value of 1 is 1. So draw your xy axis, label your axes and your scale. And then let's plot those points. So negative 1, 1, 0, 0, 1, 1. Now this graph does not have any curve to it. It's a V-shaped graph. Try that again. And so this is the parent function. Again, notice the vertex, the base of the V, is at the origin, and it opens up. Now this graph's going to be in a little bit different position because of this value. So let's plug in negative 1, 0, and 1 again. Absolute value of negative 1 is 1, plus 3 is 4. 0 plus 3 is 3. And then absolute value of 1 is 1, plus 3 is 4. Draw your xy axes, label your scale, and then plot your points. So negative 1, 4, 0, 3, 1, 4. Now as you draw this, you can tell that this V-shaped graph has not changed shape or size, it has simply shifted up. So that's how we graph absolute value functions. Now let's talk about quadratic function. So we're going to graph two quadratic functions. The first one, like the absolute value, is the parent. F of x equals x squared, or in equation form, y equals x squared. The second one, in equation form, is y equals x squared minus 2. So we're going to plug in negative, 0, and positive values. This time, I think I'll plug in negative 2, 0, and positive 2. So I need to square each of those. Negative 2 squared is 4, 0 squared is 0, and 2 squared is 4. I'm going to draw my xy axes and label. Now again, when you're watching the video and taking these notes with me, at any point in time, just pause it so you can catch up and get down what you needed to. A parabola is not pointy like absolute value. It is a nice, smooth shaped curve. If we put some extra values in between, I know those 2 points are on the graph. So it's a nice U-shaped curve. This is the parent function. Notice that it's got its vertex, its lowest point, can be lowest or highest depending on how it opens, is at the origin 0, 0, and it is opening up. Now let's look at x squared minus 2. It's still a quadratic function. It's going to be a U-shaped graph, but it's going to be moved a little bit because of what's happening in the equation. Let's do those same values, negative 2, 0, and 2. Negative 2 squared is 4, minus 2 is 2. 0 squared is 0, minus 2 is negative 2. 2 squared is 4, minus 2 is 2. Lots of 2's going on. So label your xy axes and your scale. Okay, now we've got the point negative 2, 2, 0, negative 2, 2, 2. Again, a nice smooth U-shaped curve. And then compare it to the one you just graphed. Notice your vertex has changed. We dropped down a little bit. Notice it still opens up and looks to be the same shape. It's interesting that it dropped down 2, and look what we've got here in the equation. We're subtracting 2. Make a final note for yourself that right here, these are what we call the parent, or the most basic functions. So go ahead and on number 2, absolute value, that first one that we graph, label it the parent, so that you know in your mind what the parent function looks like, and then how to go about graphing using a table of values. This is the end of the 1.1 Parent Functions and Transformations Part 1 notes. We will cover Part 2 tomorrow, and now you can work on your assignment.